Okay, so hi guys, good day. I hope you are doing fine today. And congratulations, by the way, for finishing your first module now. We have our second module entitled Fluids, Electrolytes, and Acid Base Imbalances. All right, so let's get started. Now, on the first part of your module, you will have, once again, your review of the anatomy and physiology. So what we're going to review in the anatomy of physiology is the kidneys and the urinary system this time. Now, before we proceed, since this is already a review for you, I would like you to watch um, the video, the osmosis video, and the QR code is provided here for you. Now, um, in this review, I would like to focus more on the discussions of the important concepts in your physiology. Now, I will leave to you the reading on the different parts of the um, renal system. Okay, but for this lecture, I would like you to proceed to the discussion on your nephrons. Why? Because it is the specific section of your anatomy that we will be discussing thoroughly throughout the module because most of your um, alterations or disorders under this module will have an affectation of the fluids and then electrolytes. And when we're speaking of fluids and electrolytes, as well as acid-base imbalances, then we are specifically pointing out to the filtration functions and associated functions as well of your nephrons. All right, so there are specific parts of your nephron anatomy that I would like you to remember. But first, let's try to identify what we can see in this picture. Okay, so let me just change the cursor. Now, first, by the way, this is your nephron. All right, so your nephron is the workhorse of your kidney. So when we say workhorse, it is the main functional unit that performs its function. Okay, so let's proceed with the identification of the parts. So if you were going to cut a section of your kidneys, this is how the smallest parts, which is your nephrons, would look like. All right. So first you have your renal artery, of course, and then there's a tuft of capillaries, okay, that you call your nephron. Okay. So before going to the tuft of capillaries, the blood vessel that leads into that tuft of capillaries is what you call your afferent arteriole. When we say afferent, it means going to, papunta. All right. So there is another arteriole that goes out of the tuft of capillaries. That is your efferent arteriole. Okay, so when we say efferent, palabas or paalis. Okay, so remember that afferent, going to, efferent, leaving. Okay, so these are your blood vessels. Your efferent arteriole continues to form your uh, peritubular capillaries. So these are still your arteries, but smaller. These are your capillary beds, which eventually joins to your veins. Okay, so the blood that's from your arteries eventually will converge to your veins, and of course, if it's in the veins already, it will now return to your heart. Okay, let's try to repeat that. This is from your heart. Blood is pumped through your arteries into the glomerulus, and then it leaves once again to your efferents, to your capillaries, going to your veins, and then back to your heart. Okay, there's a specific importance of these peritubular capillaries, which we will be discussing a little later. Now, going back to your nephrons. So, surrounding your tuft of capillaries, which is your glomerulus, is your Bowman's capsule. So, think of the Bowman's capsule as a funnel. Now, what happens here in your complex of your Bowman's capsule and your glomerulus? So certain substances, just like your electrolytes, um, your ammonium compounds and body waste, as well as drugs or anything that is destined to be excreted outside of the body is being filtered here. Okay, so anything that's in the blood that's destined to go out of your body will be filtered here. Your Bowman's capsule will now catch those filtrates and then funnel it into a network of your tubules. Okay, so from Bowman's capsule, now going to your tubes. Okay, so these tubes have different shapes. So if we put it that way, and there are specific sections of these tubules which function differently, okay, which we'll be discussing it later. Let's first identify the parts. So the first part is what you call the proximal convoluted tubule. All right. Now it dips down to your uh, medulla, and it now becomes your loop of Henle. Okay, so your loop of Henle has two parts. You have your thin descending limb, and then you also have your thick ascending limb. All right. So after that loop of Henle, it is a loop, right? So after the loop of Henle, it will now proceed to your distal convoluted tubules. Okay. Before it eventually drains into your collecting ducts. Okay. So let's repeat that. Bowman's capsule, proximal convoluted tubule, loop of Henle, distal convoluted tubule, and then your collecting ducts. All right. So going back to the specific function of your peritubular capillaries, it has something to do with the processes that are involved in your nephrons. So there are four principal processes that I would like you to remember in the functions of your nephrons. All right, so let me just type that in a little bit. So first, you have your filtration. Next, you have your absorption. Next is your secretion. And lastly, your excretion. All right. So where in the network, so if we will say that this is a network, where in this network of blood vessels and tubules do these specific events happen? All right, so let's try to number them. Okay. Although I have numbered them 1 to 4, several of the processes have an overlap and they do not necessarily occur in a sequence. Okay, but some others do occur in a sequence. It's like, for example, first, your filtration. So your blood components that are destined to be excreted are now filtered in your glomerulus. How? So your glomerulus is actually lined by your podocytes, and your podocytes have slits. So what happens to those slits is that it lets smaller particles get through and go into your Bowman's capsule while it prevents larger particles, just like your proteins, to be trapped, and then they go back to your vascular system. All right. So that's where your filtration occurs. Um, Filtration, you have your various substances like your glucose and more importantly your electrolytes. I would like you to remember the electrolytes in this specific section, okay, because they are the ones that have something to do with your fluid balance. Okay, the one electrolyte that I would like you to most remember is your sodium. Okay, so your sodium is being filtered here. That's step number one. So after the filtrate goes to your Bowman's capsule, it now goes to your tubular systems. Okay, so that is where your absorption occurs. Absorption actually is dependent on what your body needs. Okay, there are substances that are completely absorbed. There are substances that are partially absorbed. Okay, so an example of a substance that is completely absorbed back is your glucose. That's why you seldomly see glucose in your urine because they are completely absorbed in your tubules and then they are returned into your capillaries. So that is the function of your capillaries. So substances that are already in your tubular system can still go back to your vascular system. Okay, let me just change my cursor. Can go back to your vascular system via the process of your via the process absorption. All right. In the proximal tubule, this is where most of the electrolytes and then your glucose are absorbed. All right. So as you go down into the loop of Henle, there are specific substances that are permitted to go back, and there are specific substances also that are not. For example, your descending limb of your loop of Henle is permeable only to water. Okay, so no electrolytes are reabsorbed here. Okay, and goes back to your circulation. While your ascending limb of your loop of Henle is impermeable already to water. And this is where some of your substances, once again, are absorbed. For example, your electrolyte sodium, once again, okay, potassium and the likes. All right. So, what about secretion? There are certain substances that are not filtered in the glomerulus, but should be excreted in the urine. Okay, so let's say, for example, they did not pass through the podocytes, and instead uh, shuttled back to your efferent arterioles. Okay, let's say, for example, um, uh, other substances that are in your efferent arteriole already will now pass through your tubular systems once again. Okay, so since they are supposed to be excreted, all right, so these substances are now being secreted back into your tubular system. Okay, let's try to repeat that. When we say absorption, it has been filtered, but it goes back into your capillaries. When we say secreted, it was not filtered, but it gets secreted back into your tubular system. Okay, so that is the main difference between your absorption and your secretion. All right, so eventually, all that is filtered, secreted, but not absorbed and are already contained in your tubular systems will ultimately lead into your collecting ducts or your collecting tubule going down into your renal calyces until it reaches down into your pelvis and eventually goes down your urinary system up to the point where it now exits your urethra. That is now your excretion. So that those are the four principal processes that I would like you to remember: filtration, absorption, secretion, and excretion. All right. One thing that is not mentioned here in your module, I mean, two things that are not mentioned here in your module are specific areas in your nephrons that play an important role in your fluid balance. Those are your macula densa and your juxtaglomerular cells. So let's try first to identify where these things are located in your nephrons. All right. So your macula densa cells are actually located in your distal convoluted tubules. Okay. And your juxtaglomerular cells um, are actually also um, found around this part, afferent arteriole. But supposedly, this drawing is not accurate. Um, the distal convoluted tubule should be in close proximity to your glomerulus. It should be somewhere here. Okay. So your macula densa are here, your juxtaglomerular cells are here in your afferents. Okay. Now, what is the importance of those two substances? It is your macula densa cells that is seen in your convoluted tubules that detects, okay, uh, that detects subtle changes in your blood volume. The same thing with your juxtaglomerular cells. They detect changes in your fluid volumes. Now, one specific thing that your juxtaglomerular cells, additional thing that it does is that in response to fluid volume deficits, it now produces your renin. Okay, so renin is a substance contained in your renin-angiotensin-aldosterone system, which is a compensatory mechanism, physiologic compensatory mechanism of the body in response to a perceived decrease in your blood volume. All right, so let's try to expound more on that renin-angiotensin-aldosterone system. Okay, so proceeding with a diagram which you can find in your handouts. Okay, so what is the trigger for your for the initiation of your renin-angiotensin-aldosterone system? Actually, it is a system that is composed of several substances that eventually leads to an increase in your blood volume. Okay, there are key substances that will be mentioned a little later. But first, let's try to uh, begin from where this system is initiated. Okay, okay. Pardon for the interferences. This recording is done at night. Okay, so let's move on. So a drop in your blood pressure or a drop in your fluid volume will be detected uh, by your macula densa cells and your juxtaglomerular cells. Okay, so basically, if we're going to explain this in Tagalog, okay, let's go back to the diagram. Okay, so let's say, for example, we have a patient who has been stabbed and has lost a significant amount of blood. Okay, so since there's a significant decrease in the amount of blood that is circulating, the patient will now be hypotensive. So your kidneys perfusion will go down as well. So konti yung dugo na nagsisirculate sa circulatory system mo. And that being the case, there is less blood as well that now goes to your kidneys. So sabi ni macula densa, okay, ba't parang kulang yung dugo na dumadaloy sa mga tubules ko? Okay, so he will now tell juxtaglomerular cells to secrete renin. Okay. The same thing with juxtaglomerular cells, that they are able to detect changes in the blood volume, and additionally, they would now secrete your renin. Okay. So what happens when your renin is um, initiated? Okay. So when your renin is released from your juxtaglomerular cells from the kidney, it now converts angiotensinogen to angiotensin 1. Angiotensinogen is actually from your liver, and it is the renin that now converts it to angiotensin 1. Okay. So angiotensin 1 itself does not do much unless it is converted into a more potent form, which is your angiotensin 2. Now, in order to accomplish that, angiotensin 1 will be converted to angiotensin 2 with the use of your ACE, which is your angiotensin converting enzyme that is from your lungs. Okay, so ACE now acts on angiotensin 1 and it produces angiotensin 2. It is this substance that you should remember because it does two things. Okay, one, angiotensin 2 is actually a potent vasoconstrictor. Okay, when we say vasoconstrictor now, it makes it contracts the smooth muscles of your blood vessels, like this one, and it makes the passageway narrower. And in effect, if your blood vessels are narrower, it will now have a higher pressure. Okay, so since the initiating event is a drop in blood pressure, the compensatory mechanism is an increase in your blood pressure in order to maintain a good perfusion. Okay, so tandaan, mababa ang blood pressure, your angiotensin 2 now acts on your blood vessels and constricts them in order to raise your BP. Another thing that your angiotensin 2 does is that it now stimulates your adrenal glands. Okay, so what are your adrenal glands, by the way? If you will recall your anatomy, your adrenal glands are your endocrine glands that are located on the top of your kidneys, on each of your kidneys. Okay, so it produces a number of substances, and one of these substances are your mineralocorticoids, which comes from where? The zona glomerulosa, the outermost layer of your adrenal glands. So mineralocorticoids, um, these substances have specific functions. So an example of your mineralocorticoid is your aldosterone. Okay, so let's try to recall that one again. Once again, angiotensin 2 tells your adrenal glands to produce aldosterone. So what your aldosterone does is that it now tells your kidney to reabsorb more sodium here. So if it tells your kidneys to reabsorb sodium, by the way, your sodium and water is like buy one take one. So remember the dictum, where sodium goes, water will always follow. So with that in mind, if your aldosterone now reabsorbs your sodium in your kidneys and puts it back into your circulating uh, circulation, it also reabsorbs water with it. So if water is reabsorbed into your circulating volume, it now expands that circulating volume and increases your blood pressure. All right. So going back to that, your aldosterone tells this is a specific system, to reabsorb your sodium. Okay, so if sodium is reabsorbed from these tubules going to your capillaries, it will pull with it water. So water and sodium goes to the capillaries, and returns to your veins and gets pumped once again into your heart. Okay, so that's how it expands your blood volume. Okay, so if there's one thing, two things that I would like you to remember in this specific section of this module, it is your renin-angiotensin-aldosterone system and your electrolyte regulate and your acid-base balance, which will be discussed in another video. So let's try to review or re-enumerate the events in your renin-angiotensin-aldosterone. Dagdagan nyo na lang na aldosterone system. Okay, so let's start. Drop in BP, low circulating blood volume, kidney releases renin. Renin converts angiotensinogen from your liver to angiotensin 1. Angiotensin 1 waits for your lungs to produce your ACE, angiotensin converting enzyme, so that it could be converted to your angiotensin 2. Now, after angiotensin 2, it exerts two effects. One is your vasoconstriction, and two is it tells your adrenal glands to produce your aldosterone. Aldosterone will now tell your kidneys to reabsorb sodium and, in effect, pull more water with it in order to effectively expand your blood volume that returns to your heart and gets pumped back into your system. Okay, so just remember that and wait for the next video. Okay,